What if China colonizes Mars before NASA and SpaceX? What if China colonizes Mars first, rather than SpaceX? Elon Musk's revelation that he aims to take people to Mars within the next 50 years prompted this inquiry. But what if China came first? Will there ever be Chinese astronauts on Mars? What would happen to our planet if China colonized Mars? These questions are significant because they're not merely hypothetical, they're genuine possibilities. It would be a game changer if China successfully colonized Mars before NASA and SpaceX. The US would lose its status as the world leader in space exploration. China would become a new space powerhouse. And no one knows what would become of our world. So let's dig deeper into these questions. China is investigating ways to safely transport people to Mars and back, as well as the possibility of maintaining a long-term presence on the Red Planet. In a previously recorded discussion, Wang Xiaojing, head of China Academy of Launch Vehicle Technology, CALT, informed the conference audience that China is investigating the best choices for sustainable human trips to Mars. Noting the recent successful landing of the Tianwen-1 Mars rover Zhurong, Wang indicated that China has broader aspirations going beyond the scheduled Mars sample return mission in early 2029. These and other unspecified robotic missions to Mars, such as in-situ resources utilization tests, including extracting subsurface water from beneath the surface of generating oxygen, are intended to lay the groundwork for initial human missions, beginning with an orbital outpost, then landing on Mars' surface, and finally constructing a Mars base. The third and final stage involves the formation of an ionosphere, which will be aided by a large-scale Earth-to-Mars fleet, large-scale development, and resource exploitation. Wang reported that CALT, a subsidiary of China's principal space contractor, the China Aerospace Science and Technology Corporation, CASC, had conducted extensive mission architecture study. This involves examining the available launch periods, the orbits the spacecraft may utilize to reach Mars, and the propulsion system most suited to allow for short and long-term stays, as well as regular repeating trips. The initial robotic phase of China's exploration aspirations would rely on chemical rockets, which are already utilized for launches. According to Wang, early human missions would employ a number of heavy-lift rockets to assemble the Mars spacecraft in orbit. These would then meet and dock with a ferry stage powered by nuclear electric and nuclear thermal propulsion for Earth-Mars transit. Cargo would travel to and land on Mars independently, and a Mars Descent and Ascent Vehicle, MDAV, would transport personnel to and from the surface. Nuclear technology would allow for significant reductions in the size of Earth-Mars transport vessels. For decades, this kind of propulsion has been debated and explored, but it still requires a number of scientific advancements, and its potential application has traditionally been received with environmental concerns. Nuclear fusion propulsion and space elevator technologies have also been studied, although both need theoretical and technological advances. The ionosphere phase anticipates the development of reusable spacecraft fleets, propellant depots for recharging spacecraft in Mars orbit, and the usage of cycled orbits, a notion earlier proposed by Buzz Aldrin. Wang's idea is bold, but it is still in its early stages. China is also experimenting with Mars-based stimulation on Earth, and we presently have two bases that resemble something out of a science fiction film. Mars Base 1 is located in a dusty desert terrain of infinite red rock, with no trace of life in the parched fog that surrounds it. However, not everything is as it appears. This is not the surface of Mars but the Gobi Desert, approximately 40 kilometers from Jianshan in China's northwest Gansu province. The base's goal is to imitate life on Mars. It was built with the help of the Astronaut Center of China and the China Intercontinental Communication Center and consists of 9 capsules, including a control room, biomodule, a greenhouse lab, airlock room, medical facilities, recycling unit, living quarters, and a fitness and entertainment room. Visitors to Mars Base 1 may experience what it's like to live in tight quarters when every element of everyday life must be regulated with extremely few resources. Water must be saved and recycled to the last drop. To keep the base's residents nourished and in shape, food must be abundant in protein. And going for a walk outdoors necessitates donning a space suit and passing through the pressurized compartment. The 1,115 square meter teaching facility, which is open to the public, may only be playing pretend. But the goal is that it will inspire the future generation of space explorers and help China catch up to the United States and Russia in the interplanetary exploration game. The Mars camp in the South China appears more like a genuine base than a science fiction one. The location on the Qinghai-Tibet Plateau is noted for its steep ridges and granite mounds known as yardangs, which were produced by wind erosion over ages. they are comparable to characteristics seen on Mars' dry surface. According to the Hong Kong-based South China Morning Post, the initiative involves education, tourism, scientific research, and simulation training. After China landed a robotic rover over Mars in mid-May, the plans for the planet were revealed in detail for the first time. They consist of 3 stages: robots collecting samples and looking for a suitable base, a manned expedition to the planet, and the creation of a colony. Crewed missions to Mars are planned for 2033, 2035, 2037, 2041, 2043, and beyond. Before the crewed missions begin, China will deploy robots to Mars to investigate potential bases and develop techniques for extracting minerals. Crews would need to be able to utilize the planet's resources, such as collecting water under its surface, manufacturing oxygen on site, and producing energy, in order for humans to live on Mars. China will also need to build technologies to return astronauts to Earth. Its Mars plan calls for fleets of spaceships to shuttle between Earth and Mars, as well as massive resource extraction. To reduce travel time, spacecraft would need to use nuclear as well as traditional chemical propellants. China would have to complete round-trip flights that would take a few hundred days. According to Global Times, there are also ideas for Skyladder. Based on the concept of the space elevator, the concept has been around for almost a century, but it has gained popularity in recent years as a result of improvements in material science. According to the Chinese concept, a manned or cargo space capsule would travel down a carbon nanotube ladder to a space station before being released. To create it, space engineers would need to start with a massive space station in geostationary orbit and work their way down. They would gradually construct a cable from the station to Earth, where it would be attached to a weight at the surface. A concrete base would have to be erected on the equator, which would rule out Europe and the United States. Despite the fact that China has made significant progress in its space exploration missions, but one guy stands in their way of being the first to reach Mars: Elon Musk. SpaceX CEO Elon Musk has long dreamed of building a metropolis on Mars. It would be self-sustaining, home to 1 million people, and would help mankind evolve into a multi-planet species. It's Musk's most ambitious objective, and it might keep him busy for the next 3 decades. How will Elon Musk construct a city on Mars? The Starship is key to the plan. SpaceX will be able to fly personnel and goods to Mars using this fully reusable rocket, which is presently being developed in Texas. The ship will be able to launch more than 100 tons or 100 people into space at the same time. Because it runs on liquid oxygen and methane rather than rocket propellant like the Falcon 9, explorers may travel to Mars, recharge using resources discovered on the planet, and return to Earth. The astronauts may even travel deeper into space, establishing a network of recharging stations along the way. The ship is set to fly for the first time this year, while the company's first objective is to launch the spacecraft from the Starbase facility in Texas. Musk has stated that the crew is also planning to launch from Cape Canaveral in Florida if there are too many delays. This backup plan may have caused a delay in Starbase's planned expansion. Musk announced in 2017 an aspirational plan to deploy 2 cargo ships to Mars as early as 2022. In 2024, it would deploy 4 ships, 2 crewed ships and 2 cargo ships to the next closest approach. However, Musk said on Twitter in March 2022 that a more plausible timeframe for mankind to witness the first humans on Mars would be 2029. It's also plausible that Musk was referring to the 1969 moon landing, putting a 60-year gap between the 2 achievements. Mars and Earth orbit each year once every 26 months. At this point, the distance between the 2 is approximately 33.9 million miles, the best time to travel. Musk tweeted in March 2019 that it's conceivable to build a self-sustaining settlement on Mars by 2050 if we start in 5 years and take 10 orbital synchronizations. With 26 months between synchronizations, construction of the metropolis would take at least 22 years. Musk has set a goal of establishing a self-sustaining Mars colony with a population of 1 million people by 2050. That year, Musk would become 79 years old, and no one knows what future holds. Given that SpaceX has yet to conduct its maiden orbital flight with the Starship, it is doubtful that the first cargo ships would be launched this year. If SpaceX's plans are adjusted to a more realistic late 2020s timeframe, Musk may be able to fulfill his target. Only China, with an ambitious program of satellite launches and space exploration, is likely to compete with Musk. The question in 2022 is not whether SpaceX will lead the industry, but whether any other company can compete. So will China succeed in the space race?